Hey, welcome back everybody. So I've had so much interest in this small block Ford build and so many questions and so many people, curious about how these heads compare. So this is a 66 289 head and this is a GT40 head. This is not the GT40P, it's just the GT40. So I want to compare these heads side to side, and as you can see, we've got the flow bench in the background, and I'm going to flow test these, and we're going to look at the flow numbers and compare them. I want to do a real world test so we know just exactly what the difference is. Now, some of the differences on the heads here. This is actually the closed chamber 289 head. It has a really tight chamber, I think it's like 54 cc's, but it has little dinky valves. If you compare the valves to the GT40 valves, the GT40 valves are quite a bit bigger, and actually we're gonna go probably with a bigger intake valve on this one. The GT40 has a bigger exhaust valve than the GT40P, and it's actually bigger than 1.5 inches. Okay guys, so we've got the 289 on the flow bench. We're gonna flow this at 28 inches. Now you might notice I got this mouse trap thing going on here. In order to flow correctly, you have to have a plate on the intake, otherwise the air becomes too unstable. This kind of duplicates the intake. I have a Ford plate somewhere, but I can't find it. So we adapted this plate and it fits the port good. So we're gonna go ahead and flow, and I've got the numbers here. What I did is I separated the 289 and the GT40 heads, and as I go through and flow it, I'm gonna write the flow numbers for intake and exhaust. And then once I flow the 289, we'll do a side by side and we'll do the GT40, and then we'll compare these numbers so we can really find out, there's so much disinformation out there on the internet about what these heads do. I do know they flow better and they make more power, but now we're gonna find out just exactly how much. All right, so here we go. So first of all, we're gonna turn the flow bench on and we're gonna make sure that we don't have any leaks. So I'll try to move this over. I've got my flow numbers up here on the computer screen. You're not probably going to be able to see that, but I'll be able to write them down. So first of all, we'll turn this on and make sure we don't have any leaks on this head. All right. So that is showing 0% flow right there, okay? Now we're going to set this for 0, and we're on the intake, and we're going to go 100 thousandths at a time. All right, so here we go. That's 100 thousandths flow there. At 100 thousandths, it's flowing 51 CFM. Now we'll go to 200. Okay, I had to make an orifice change because the flow is over speeding the machine. Now you'll notice I'm putting my finger on the spark plug hole back here because I don't have a spark plug here anywhere for the older head. But I did test it with my finger over there, and I've got 0% leakage, so I know I'm blocking that flow off. You don't ever want to flow a head without the spark plug in it, man. It'll flow numbers like crazy. Be the best flowing head you ever had. All right. All the way to 600 on the intake. Not that we needed to do that because it doesn't flow at all up there. So we gained almost nothing. We literally gained 2 CFMs from 500 to 600. That's pretty bad. And these numbers are not great. I mean, we're flowing like 161 at 600 lift, and it went from 159 to 161. That's terrible. That is not good flow. All right, so we're going to switch to the exhaust. I'll change the direction of the flow. Instead of sucking in, we'll be pulling out. All right, exhaust. Now let's leave the valve closed, do a test, make sure we have no leaks here. There you have it, guys. So let's take a look at this. So 51, 102, 142, 153, that's a pretty good spread from 200 to 300. When we get to 300 thousandths of valve lift and go to 4, we gained 11 CFMs. Not real great. That's why the cams only have like, I don't know, a little less than 400 lift factory, because that's what this head flowed. We go from 400 to 500 lift and we gain 6 CFMs. The amount of force you use to actuate the spring is going to be more than what that amount of air is going to produce in power. From 500 to 600, things really go into the toilet. We're moving the valve a whole 100 thousandths here, and we're gaining 2 CFMs. So, yeah, those heads, this is why when guys put big old cams in the old 289s and 302s, with these heads on them, they run terrible. So, and then the exhaust over here, we'll go through that and figure out what our percentage of flow is. But our max flow on this thing, we're going to say 153. We're not really going to go to 500 lift and say 159, because that's just not, you wouldn't do that. All right, so GT40 set up, and we'll see what it does. Okay, guys, we've got our GT40 set up on here with our Brzezinski mousetrap, and first of all, we're gonna make sure we don't have any leaks, so we'll turn it on with the valves closed. And we are starting on the intake, so we're gonna pull air in. I gotta change the direction of the orifice. Okay. Now, the thing is, compared to aftermarket heads, these numbers, I mean, when you look at the numbers of the GT40, it's like, oh my gosh, it's not that great. It's like, it's about like a decent flowing like fuelie head off of a 350 Chevy or something. But when you compare it to what the 289 did, it's like, oh my gosh, no wonder we see such an improvement. Okay, so we're going to go to exhaust, and then once we get the exhaust done, we'll be able to compare these numbers. Switch the direction of flow here from sucking to blowing. Okay, here we go. Last one, the exhaust port on the GT40 head. Valve is closed. I have 0 flow right there. Okay, now we're going to open this thing 100 thousandths. Okay, sorry guys, I screwed up. I was not changing the orifice size, and I was out of range for all these numbers except for the first one. So those are not right. I was wondering why it was so low. Okay, so we got to go to the next orifice size. Out of range. That's good. When it goes out of range, when you go up 100 thousandths, that means the flow increased a lot. The 289 head, from like 400 to 600, it didn't go out of range. It stayed in the same range, so we didn't gain hardly anything. so this is very interesting. This is very telling, guys. Let's take a look at our numbers here. All right, so here's what we've got. Well, the 289, our flow numbers were 50, 100, and then it just dropped off like dropping off a cliff after 300 thousandths lift. So, but if you compare the numbers, 100 thousandths on the intake here, GT40 64. 100 thousandths on the intake here, 51 CFMs, GT40 64 CFMs. At 200 we had 102, we had 119 on the GT40. So it beats it all the way through the entire range. We get to 300 thousandths lift on the 289 head, we got 142 CFMs. Over to the GT40 159. Get down to 400, we hit 153 CFMs on the 289, 182 on the GT40, and then we get to 500 lift on the 289, which would be totally pointless, 159 CFMs, and almost 200 CFMs, 198 on the GT40. Now look at the difference from 400 to 500 here. We gained 6 CFMs on the 289. From 400 to 500 here, we gain a significant amount. We went from 82 to 182 to 98. That's like 16 CFMs. That's worth it. It would be worth it to run a 500, 510 lift cam. And things kind of went south here. We went from 198 and these things fall off a cliff. Don't put a 600 lift cam with a GT40 head. The thing fell off a cliff. And you look at the exhaust numbers here, we gain, right? Even from 4 to 5, we lost a couple CFMs, but that's not a big issue. It falls off a cliff going from 5 to 6. So I would say 480 to 510 lift is ideal for these GT40 heads. But you can see the difference, man. I mean, they just killed the 289. Now, we can figure out the percentage of flow too, because that tells us a lot too. So the percentage of flow for the 289 head, we're going to take our highest number right here, and we're going to divide the difference. We're going to divide 153 into 97.2. We got 63% of flow. So in other words, what percentage of the intake is the exhaust flowing? That's a big deal for horsepower. If you go to my first cam video, you can walk through the numbers. It'll tell you how to judge, how to use those numbers and figure out your potential horsepower. Now again, there's a lot of other factors here. When you do the math to get the potential horsepower of the head, that doesn't mean that's all the horsepower the engine's going to make. We use this, I mean, there's compression ratio, there's RPMs, there's induction systems, there's all kinds of other factors that factor into the horsepower output. All the way down to the efficiency of the chamber, right? So if we go to our max flow here, which is 500 lift, and we look at 198 and 136, we want to know what percent of flow this GT40 has. So the GT40 has 68% of flow, so 63%, which is terrible. 68% is not great, but it's better. And actually on the GT40, if you were to do a little porting on the exhaust or put a larger valve in there and cut the throat, you could probably get this number up to 145, 150 maybe, and your percent of flow is in the 74, 75% range, which is really good for a street motor. So overall, the bottom line of this, guys, is the GT40 heads are way better than the factory 289 heads. I mean, in every lift point, in every area, they're better. Now that I've seen this for myself, and I've done this before in the past, but I never really compared the two, GT40 heads are well worth it. I mean, they are, I don't know, I can't even tell you. I mean, you can't believe the difference that's going to make in your engine. That is like a night and day difference. And these are heads that you can pick up for a couple $100 at the boneyard, put them, and again, I didn't do, you know, all the work that you saw for the 289 build that I did to Charlie's motor. I didn't do any of that to this head. This head, I cleaned it up, blasted it, touched the seats, and put a couple valves in it. Those are stock GT40 valves, right? I wish I would have flow tested Charlie's heads after I did all the valve work and some of the bull work, but I don't know, I might still do that. I don't know, I haven't even put the head bolts in those yet. I think I might do one of Charlie's heads. I'll just take it back off the motor and bring it down here. Who knows, we'll see. But overall, the bottom line of it, guys, is get yourself a set of GT40 heads or aftermarket. Take the 289 heads. If they're original to the car, stash them on a shelf somewhere. But if you want to make any kind of power, and I'm not sure what Charlie told me what the 289 two-barrel horsepower was. I think it was like 180 or something like that. So we're looking to, I'm hoping to see 235, 240 horse with all the upgrades that we did, maybe even 250. Doesn't sound like a lot of horsepower, but when you got 180 and you go to 250 or 240, that is a significant gain in a light car. It's gonna make a difference. It's a great upgrade. So I appreciate you watching. I think I'm going to try to do one of Charlie's heads because this would be interesting to see how the big valve conversion and a little bit of the match porting and stuff help those heads. Okay guys, so I know it seems like this was instantaneous, but the flow bench stuff that you just saw was like 2 days ago. I actually did a lot since then. So what I did is I did pull one of Charlie's heads off that we reworked for his 289, and I took it and I floated. I didn't film all that because I mean it just kind of seems silly for you to sit there and watch the flow bench make all kinds of noise. So I did that off camera, but you get the idea on how we do it. And so here's what I did. I got the 289 flow numbers that we got on the flow bench. I got the GT40 flow numbers. Then what I did is I didn't have a GT40P head that wasn't modified. So I got on the internet and I got the GT40P numbers. I looked at multiple sites that are reputable, and I got the GT40P numbers with the stock valves. And then I went ahead with the bigger valves that we put in Charlie's head. I flowed those so we could see the difference. So I want to take a look at these numbers and show you what we're looking at and show you why it's a good idea to upgrade these heads. Okay, so I want to zero in on these numbers here. So this is our 289, and we looked at these numbers already. As we progress down here, if you look at the GT40, the GT40P heads, they're definitely an improvement over the 289. We know that. The other thing we want to look at is percentage of flow, and I'll talk about that in a minute. But if you compare the max flow, we'll say 500 lift, with the 289 and the GT40 and the GT40P heads with stock valves, I didn't even bother going to 600 lift here because the flow just falls off a cliff. There'd be no reason to run a 600 lift cam in this thing. I did put the numbers for 600 lift on the modified heads where we put the big valves in because there's a little bit of a gain there. Actually, we lost and gained. I wouldn't put a 600 lift cam in that either. So, but let's compare this. So the stock GT40 head, we looked at these numbers already. Our max flow is 198 CFMs and 136 on the exhaust. That gives us 68% of flow. And we'll talk about the horsepower potential of these heads in a minute. I did it already in the last video, but I want to zero in on that. If you look at the GT40P heads, what's interesting is the GT40P heads, they flow better. Well, really, if you look at up here, they're identical at 100 thousandths valve lift, but I mean, that's not a big issue. You can look at the numbers between the GT40 and the GT40P. At 200, we gained 6 CFMs, but we lost on the exhaust. Now remember, that GT40P head has a smaller exhaust valve than the GT40, and that's kind of showing up here. We can see that. So we gained intake and lost a couple of exhaust. 2 CFMs is not a big issue. We go to 300 lift. The GT40 has 159 and 128. We go to 300 lift, we got 166 on the intake for the GT40 for the P head. The exhaust is 8 CFM less, so we're losing on the exhaust on that. One of the things that this really brings out is the fact that with the P heads you can really improve it if you get those exhaust numbers up. 195 and 132, again, we have less exhaust flow here than we did with just 40 head as opposed to the P head. We get to 500 lift, we got 196 with the GT40. What's interesting here is we actually lost a couple of CFMs on the intake and we gained a couple on the exhaust. So it kind of flip-flopped there. So I thought that was interesting. Now, we go over here to the heads that we did all the valve work and a little bit of the match porting and stuff. So you can see with the bigger valve, we gained 3 CFM. Here we gained 7. Here on the intake, we went from 166 to 171. 197 to, or 195 to 197, not earth shattering, but we're going in the right direction. And a 500 lift, we went from 196 to 209. So it seems like at the higher lift, the bigger valve is making more of a difference. But the really significant increase that here is the exhaust. So we have that little dinky exhaust in the P head, but we went to the bigger exhaust, and we went from 50 to 62 on the exhaust. We went from 90 to 103 CFMs on our exhaust. 120, we gained 6 CFMs here, gained 6 CFMs here, and at 500 lift, we went from 138 to 144. So we gained all throughout that range with that bigger valve. Actually, it's flowing better than the GT40 did, right? It's the same here. It's got 138, 138. We got 128 here, we lost a little bit here, and then we definitely gained here. So it's kind of a mishmash of gain, but overall, the increase in flow with the big valves definitely, you know, it's not earth-shattering, it's not life-changing, but we did go in the right direction. Now let's look at the percentage of flow. So at maximum lift, the percent of flow is a thing too here. So the percentage of flow is at my max flow point, wherever that is, and in this case it's 500, and this one we did it at 600. What percentage of the intake flow is the exhaust flowing? Now we need to know this because this is a factor in calculating the potential of the head. The stock 289s had 64% of flow, and I'm actually being generous there. It was more like 63.5 or something like that. The GT40, 68%, which is decent. The GT40P had 67%, and then we bumped the GT40Ps with the valve work up to 68%. So let's take a look at these percentages, and we'll talk about what they mean. But the reality is, going from the 289 all the way to the P with the big valves, if you look at these numbers and you look at these, it is a significant difference, right? Our max flow is like 159 on the 289, and we're going all the way to 209. That's like a 50 CFM jump. Now we're talking 40, 50 horsepower there, so maybe even more than that. All right, so let's take a look at these percentages, and I want to show you how these numbers actually relate to power. I did this in the first cam video, but I want to actually do it with the Ford heads that we're working with here. So let's take a look at these numbers. So our 289, let's talk about those stock small valve little dinky port 289 heads. We got our max flow point, and you saw the numbers earlier. So what we did is we calculated our percentage of flow, because this is a factor in calculating the horsepower potential of the head. Now I want you to keep in mind, I'm going to throw out a disclaimer here. These numbers that we've got here are just a general ballpark type number that we use. These numbers, this math was put together by Superflow many years ago, and the reality is the horsepower that your engine actually produces can be higher, significantly higher than these numbers, or it can be lower depending on the size of your engine, your intake and induction system, the condition of your engine, your compression ratio. There's all kinds of other factors. So I know that people are going to do this math on their head, and they're going to be like, according to your math, my engine should only make 320 horsepower. It's making 400, okay? Well, I get that, right? This math is just to give you a general idea and how to compare head. And a lot of times we can actually get more power than this, especially if we modify the engine. This doesn't take into consideration the camshaft, the efficiency of the chambers, the induction system. It doesn't take any of that into account. We're simply trying to compare these heads and see which one is actually going to make more power in the real world. Okay, that's what this is about. So our 289 head, we took the exhaust and the intake flow, the max exhaust and intake flow, and we divide those two. We actually divide the intake flow into the exhaust. We divide the larger number into the smaller number, and that gives us a percentage. In other words, what percentage of the intake flow is the exhaust flowing? Okay, we need to know that because that factors into this. So we came up with 64% of flow, which is pretty typical for a low performance stock head. It's not really great. Our max flow on that head, at our maximum flow, is 159 CFMs right here. So all that thing flowed, which is terrible, by the way. Now, we're gonna multiply our maximum CFM by 0.26. Now what the .26 is that is how much horsepower the head is potentially going to make per CFM of air if we flow the head at 28 inches, which we did. We flowed these on the bench at 28 inches of flow. These are all flowed at 28. It was pretty much the industry standard. 159 CFM times .26, and that's going to give us potential horsepower per cylinder. So if you multiply that, you get 41.34 horsepower per cylinder. Now remember, it's an 8-cylinder engine. So we got to take 41.3 horsepower and multiply that by 8, and that gives us a total potential horsepower of 330 horsepower with that 289 head flow. Now, that's not the end of the story. I can tell you right now, those 289 heads would not make 330 horsepower if you strapped a rocket to them and dropped them off a cliff. The percentage of flow is a big factor in how much this is actually able to produce. So the percentage of flow on these is 64%. So the exhaust on that cylinder is flowing 64% of that 159. So what we do is we take the total potential horsepower here, right, which is 330, and we got to multiply that and factor in the percentage of flow. So if we take 330 horsepower and we factor in 64% of flow, we get a realistic potential for this head of 211 horsepower. Now, keep in mind, these numbers, when Superflow did this, were actually based on an engine with a 4-inch bore and a 3.5 to a 3 3/4 inch stroke. 289 is a much smaller cubic inch, so you're probably going to lose some of that just because you don't have enough volume in the cylinder. It will do it if you put real high compression pistons in there, and you could get it to do it, probably even more than that. But we're talking realistic here with a flat top piston and just like a basically modified 289. So you're probably going to, now I think the engine was like 280, no, it was like 185 to 190 horsepower from the factory. So, and that's with stock exhaust manifolds and a 2-barrel carburetor and all that nonsense. So, all right, so we go to the GT40 head. Percent of flow is pretty good on the GT40. A lot better than the stock head. So if we look at we had 51 for our max flow. We had 198 CFMs on this one. Multiply that by 0.26, you get 51.4. Multiply that by 8, total potential of that head is 411 horsepower. Now, we got to look at our percent of flow again. 411 horsepower times 68% is 279 horsepower. So that head horsepower potential, realistic potential, 279, 280. Okay, I'll buy that. Then we go to the GT40P head with the stock valves. Now, I want you to notice something here. Remember, the P has a smaller exhaust valve than the 40. Look at our percentage of flow. Our exhaust flow is a little bit lower. Our intake flow was higher, right, in most of the range, and you got to kind of take that into consideration. But our maximum intake flow was actually lower than the GT40 head. Okay. So when we look at the lower exhaust flow, now one of the things that really comes into play here is with the small valve, we have a lower percentage of flow. What that tells us is, hey, if we put a bigger valve in and cut the throats on the exhaust and maybe port the exhaust, this head, we can get that potential way up. We did that with the bigger valves and the throat work. We didn't even port these heads, and I'll show you the difference that makes. So on this one, we had a total potential of 407 horsepower because we had a little bit less flow at max and a little bit lower percentage of flow. So our percentage of flow, we take 407 times 67, and our total potential horsepower is pretty close to this. It's actually 276 horsepower, just slightly less than the actual GT40. So those of you that say, oh yeah, man, the GT40P heads are way better, you know. Well, they are in a lot of the flow range, but when it comes to max flow, they're really not much different than the GT40 head. These heads are, I mean, if you're gonna knick-knack about 3 horsepower, oh, I gotta spend way more money because I need 3 horsepower, that's a waste of time. 3 horsepower, you're not gonna feel it, doesn't make a dang bit of difference. All right, so that is where we're at. Now we come over to the GT40P heads with the bigger valves, which I flowed because I wanted to know. 213 CFMs for our max flow times 0.26. That gives us 55.3 horsepower per cylinder. Multiply that by 8, you get a total potential horsepower of 443. Definitely higher than these. Our percentage of flow was 68%, same as the GT40 heads. So we take 443 times 68% to get our realistic number, and we come up with 301 horsepower of realistic total potential horsepower for over all the cylinders. Now that's pretty good. Again, there are other factors, the size of the engine, the compression ratio, the induction, the exhaust system, but according to Superflow math, the best horsepower, the best flowing head here is going to be the GT40P with the big valves. Now, the difference between 276 and 300, yeah, that's, you know, that's a pretty good difference. It's like 24 or something like that. 25 horsepower maybe. Yeah, I think it's worth it if you can do the valves. But again, if you want to just bolt on one of these heads, I don't know, I think the GT40, the drawback to the P heads here is that they have the small valve, plus they have a weird angle on the spark plug. You got to buy special headers. You're going to make just as much power with a set of GT40 heads. Now, if you take the GT40Ps and you do valve work on them, maybe a little bit of cleanup on the ports, you're definitely going to make more power. The contrast that I want to make, though, you guys, is this here compared to that. So we're talking about a 90 horsepower potential gain going from the stock. And again, these flow numbers, if you look at the aftermarket cylinder heads, the Edelbrock heads are about 10 or 15% better than these P heads with the valves. They are better, but they're twice the cost. Now, if you really want to get into, you know, you really want to make big power, and I don't know why you'd use a 289, but if I'm going to make big power, I'm going to go with bigger cubic inches. Then you can get into the Dart and the AFR heads and stuff like that, and now you're talking, you know, the sky is the limit on horsepower. You know, there's 351 Windsors, 700-800 horsepower. We're going to do the 351 Cleaver motor here pretty soon, and it's going to have Edelbrock heads and a Dart block and everything else. So okay, so that's it. You know, the flow bench doesn't lie, you guys. And again, big disclaimer: your horsepower may be less or more than this depending on all the other variables. You know, if you put a big dish piston in there and you're running, you know, 8-to-1 compression, you're not going to make that kind of power with those heads, especially with a small cubic inch motor. So this is simply a comparison between how these heads stack up against each other based on flow numbers and their potential to make horsepower on the engine. So I hope you enjoyed this. You can pause this and take a look at it if you want. I got a lot more stuff coming. I do appreciate you. It's been a long last 24 hours because I went back to the shop with the flow bench twice and pulled the head off Charlie's engine, flow tested it, and came back and forth, and then I forgot my battery charger for my camera and I had to go back down there. So it's been crazy, but I wanted to get this video done because this is something I believe, you know, it's one thing when people make videos and they got, you know, it's like, oh yeah, we spent $90,000, you know, modifying our car, you know, chip foosted this and that, and it's like the average person is like, where am I going to get $90,000, you know, for a, you know, 4,000 horsepower motor and a street rod and all that stuff. So a lot of the videos you see, it's just like, man, you know, that's cool, but there's no way I'm going to be able to afford that. Listen, you guys, you could afford this. You could do this. You know, these heads with the big valves in here, you'd probably only have $700 or $800 into a max if you had somebody else do the work. Honestly, if you took some GT40P heads, we're talking 150, 200, 300 bucks. You bolt them on and you got a significant gain in power for your small block Ford. You add in a nice camshaft that's probably 480 to 500 lift and make it a roller. Now you got something. All right, so I appreciate you watching. Thank you very much. I will talk to you very soon, I promise.